The second part of 7.1, we're going to do a little bit more with inverse trig functions, and it may have seemed a little confusing or we're going too fast at the end, so this section is really meant to give you a little more clarification on why inverse trig functions and their domains are so specific. And we'll actually be able to do a lot of these by hand, just by knowing where these two different functions exist. Okay, so how we're going to do this is we're going to start off by graphing our three trig functions, and then we're going to show you the graph of the inverses. And just as a heads up, I'm going to ask you to know the shapes of the inverse functions for the upcoming test. So just be prepared for that. Okay, so we're going to graph our sine graph from negative pi over 2 to pi over 2. So sine was 0 here at 0, and then we go up to our amplitude, and we go down our amplitude, going backwards. So our just our basic sine graph from negative pi over 2 to pi over 2 looks something like this. If we continued on either way, our function would stop being one-to-one. Now I want you to remember, we did this in level 5. In order for a function to have an inverse, it needs to be one-to-one, which means it passes the horizontal line test. So that's review, we should know that. Why I'm limiting the domain for each one of these graphs is for it to pass the horizontal line test, and so that I can have an inverse. So if we look and see that our highest values are 1 and negative 1, that means our domain for inverse sine is going to be where x is between positive 1 and negative 1. Okay, so negative 1, positive 1. And if you remember graphically, to find the inverse, we switch the x values with the y values. So that's exactly what we're going to do. So our y values then are going to be pi over 2 and negative pi over 2. So instead of being at pi over 2 negative 1, we're going to be at negative 1 pi over 2. And still going to be at 0, 0, and we're still going to be at 1 pi over 2. So the graph of this looks something like this. This is the inverse sine function and what it looks like. Our domain is from negative 1 to 1. Our range gives us our output. Our y values are between pi over 2 and negative pi over 2. Because if we go here, our domain is between negative pi over 2 and pi over 2, and our range is negative 1 to 1. We're just switching the domains and the ranges. So the numbers that you can plug in to the inverse sine function are any number between negative 1 and 1, and your output will be from negative pi over 2 to pi over 2. Okay. For inverse, so graphing cosine. Cosine is a little bit different because we're going to graph it from 0 to pi. Now remember, cosine starts at the amplitude, then it goes down, and then it goes down to negative 1. So cosine looks something like this. This also passes the horizontal line test. If I went back any further, it would fail. If I went further past pi, it would also fail. Okay, so knowing this, we're going to graph our inverse cosine graph. If we see that our domain is going to be different here, our domain is going to be from, well, still negative 1 to 1. And our range is going to be from 0 to pi. So how do we graph this? Well, let's do a slightly different color. our domain is from -1 to 1, and our range goes up to pi, and this will be pi over 2. Well, when cosine is 0, the y is 1, so we switch those. When the cosine is pi over 2, the y is 0, so we switch those. And cosine is -1, we get pi. So inverse cosine looks something like this. And all we're doing is we're switching the x values with the y values. That's how we get our new domain and range. So this is inverse cosine, and this is inverse sine. So those are our domains and our ranges. Last up, if we're graphing tangent, well, tangent from -pi over 2 to pi over 2 is 1 period. So we will have our vertical asymptotes at -pi over 2 and pi over 2. We'll have our zeros there, halfway points, halfway points. We go up and down our amplitude, and we look something like this for inverse tangent. Okay, so that means for inverse tangent, our new domain is going to be the range here. So our domain is going to be all reals. Our range, our output is anything from -pi over 2 to pi over 2. So -pi over 2 is less than or equal to y, which is less than or equal to pi over 2. If we're wondering what the graph looks like then, again, switch the x's with the y's. We're going to do this in blue. Our highest point will be pi over 2. Our lowest point will be -pi over 2. And instead of being vertical asymptotes, we're going to have horizontal asymptotes. Inverse tangent is still 0 at 0. If we went -1 and 1 left and right, we would be at -pi over 4 and pi over 4 respectively. So we can just graph those points there and there. Those give us our 3 points that we're going to connect the dots with. Okay, so these are our 3 graphs that we're working with. And it's super important that we know, are we either looking at a sine function or are we looking at an inverse sine? Are we looking at cosine, inverse cosine? Are we looking at tangent or inverse tangent? Okay, now why is this so important? Well, as we stated a long time ago, inverse functions or functions undo each other. So if I have the sine of the inverse sine, I should just get whatever the number is on the inside, as long as it's inside the domain. So each one of these numbers must be in the domain in order for it to work. So is 1/3 in the domain of inverse sine? The domain for inverse sine is between -1 and 1. It is, so the sine of inverse sine is just 1/3. Another way you can look at this is it's saying this thing right here is our angle. What's the sine of this angle? Well, this would be 1/3 because it's in the domain. Same thing here. Cosine of inverse cosine of -2/3. What's the domain for inverse cosine from -1 to 1? So that's in the domain. So that means that the cosine of inverse cosine is just -2/3. These two undo each other. Tangent. Tangent of inverse tangent of 4, or if this is our angle, what's the tangent of this angle? Well, is 4 inside our domain, which is all reals? It is, so that's just 4. Now, here's where we get a little tricky. The cosine of inverse cosine of 1.2. 1.2 is not in our domain. So this doesn't yield a valid answer, so there is no solution because 1.2 is not in domain of inverse cosine because we're from -1 to 1. Can't just plug in 1.2 because then it fails. How about the sine of inverse sine of negative 2? Well, is negative 2 inside our domain? Our domain for inverse sine is negative 1 to 1. So this is also no solution. Not in domain. The tangent of inverse tangent of pi. Is pi inside the domain of inverse tangent? Yep. So we just get pi as our answer. The sine of inverse sine of negative 1.5, that's no good because negative 1.5 is not inside our domain. Tangent of inverse tangent of negative 2 is because that's a real number. So that's what we're doing. So it's super important that we recognize the domain of our function and the inside. We always work inside out. So if you have cosine of inverse cosine of negative 2/3, make sure that that inside number is in the domain of inverse cosine first. We could have it flipped. We could have the inverse cosine of some angle. And we have to make sure that whatever the cosine of that angle is falls inside our domain. All right, so let's flip it over and we'll do a couple more. So as I was saying on the front, what we should know about using these inverse functions and going back and forth, in order for, if you had the inverse sine of sine, you have to make sure that your x values are between negative pi over 2 and pi over 2. If you're going from sine of inverse sine, we do the inside functions domain first. This is our composition of functions that we've talked about a long time ago, which would be negative 1 to 1. Same thing with cosine. If you have just a cosine value, you have to make sure your angle is from 0 to pi first. Or if you have inverse cosine on the inside, you have to make sure that your numbers are between negative 1 and 1. Likewise, for tangent, if you have the tangent on the inside, make sure your angle is between negative pi over 2 and pi over 2. If you have the inverse function in first, then it doesn't matter because you'll get a number out and then you can just plug it into the tangent function. So utilizing all of this to find our inverse functions, we're going to do the exact same things that we did in level 5. So remember our 6-step process. First, if we were finding an inverse function, we're going to write it in terms of y. So first we write y equals 2 sine x minus 1. Step 2, switch the x's with the y's. So we have x equals 2 sine y minus 1. Then we're going to solve for y. So we add 1, x plus 1 equals 2 sine y. Divide by 2, x plus 1 over 2 equals sine y. And now we get here, and the only way to undo a sine is to take the inverse function of both sides. So the inverse sine of sine is just y. So we have y equals inverse sine of x plus 1 over 2. Now the last question says, what are the domains for each? So the domain of f of x, well, is there any restrictions on what x can be? Here, no. X can be all reals because it doesn't matter. For our inverse function, the domain for our inverse function, inverse sine is between negative 1 and 1. If we need a chart, we can look up here. We can see that inverse sine is negative 1 to 1. So we want the inside to be between negative 1 and 1. Well, the inside is x plus 1 over 2. So to solve this out really quickly, you get negative 2 is less than or equal to x plus 1. So less than or equal to 1. Subtract 1 from both sides. You get negative 3 is less than or equal to x, which is less than or equal to 0. This is the domain for our inverse function for numbers that would work. All right, couple more. So we can find the inverse function. We can also solve inverse functions. So what we do here, solve the equation 3 inverse sine x equals pi. So first get the inverse function by itself. So divide by 3. So we want to know, here's one way. Let's just go through. Take the sine of both sides. These will cancel each other out. X equals, what's the sine of pi over 3? Well, if you know, I can just look at my hand. Sine of pi over 3 is root 3 over 2, which is definitely between -1 and 1. So that's our answer. 2. First step, divide by 2. Inverse cosine of x equals pi over 2. Take the cosine of both sides. X equals the cosine pi over 2. What is the cosine of pi over 2? We're looking at the x value, which is just 0. Is 0 between -1 and 1? Yep. So that's how we solve these inverse trig equations. And that takes us through 7.1. Make sure you ask me any questions you have on this section.